Number 14 is our LOC and probability of homozygous dominant given a clean test question. So we have the slick locus. So this S dash, so our S and S little s have the short slick coats, while S little s, sorry, my S's all kind of look the same, is our normal coat. So these guys with the slick coat are better adapted to hot conditions in the tropics. So a bull that's suspected of being, this is right here giving us our probability of being heterozygous based upon pedigree is 0.67. They then mated him for 2 consecutive years to 2 slick coats cows that have previously produced calves with normal hair coats. So in order to produce animals with normal hair coats, they have to be heterozygotes. So we know that these testmates that he was bred to were in fact heterozygotes. So their probability of being homozygous dominant is equal to 1, heterozygote is equal to 1. Probability of being homozygous dominant is equal to 0, and probability of being homozygous recessive is also equal to 0. And we need that for our LOC question because he gave birth to calves with all slick coats, so he passes our progeny test. So our initial probability of being homozygous dominant is 1 minus 0.67 because this is his 0.67 is his probability of being heterozygote. Then we have to go into the LOC. 1 minus, we already specified that for his testmates, probability of being homozygous dominant is 0. Probability of being heterozygote is 1 times 3/4. These cows all had 1 offspring. And we also said their probability of being homozygous recessive is 0. So if we think about it, they had 4 calves in total. So you could do this 4 times. Or since they were bred 2 different years, you could do it this 2 times with the exponent of 2. Or, so it would look like this. Or you could just combine these together and put an exponent of 4. It will give you the same answer because we have this 1 right here. If we had other fractions in here, we'd have to look at it a little differently. But all in all, our LOC is 0.6836, and that's our level of confidence in this test. And then we're looking for the probability of being homozygous dominant given a clean test, which is this equation. So we need the initial probability, which we calculated as 0.33, over 1 minus the LOC times 1 minus the initial probability, which in the end gives us an answer of 0.6088, or answer D, 0.609, and that is our probability of this animal being homozygous dominant given the clean test. Moving on to number 15, genotype environment interaction examples. All are correct except. So if we think about genotype environment interactions, we're thinking about animals that differ in their genetic potential. And when they differ in that genetic potential, they differ in performance in different locations. So really, if you look at these, A through C are all talking about different types of breed types performing differently in different locations. So southern New Mexico, south central Nebraska, Hereford cows in Florida, Montana cows. The opposite was true in Montana. So A through C are all talking about different locations, different breed types, and different performances. But when we look at letter D, which is the correct incorrect answer, it doesn't talk about environment or anything. It's just stating that mules are better for farm work than horses. So that is not an example of genotype environment interactions. Number 16, breed characteristics. Breed characteristics influence performance of animals in a production system as components of production system complementarity. We know that production system complementarity influences performance. Additional advantages above contributions of production system and complementarity. So there are certain breed characteristics that do contribute a lot to performance that don't have to do with production system complementarity. So then we have our components to maternal contribution, so the maternal contribution to performance, and then the the progeny contribution to performance, because, you know, if a progeny is a different type of crossbred than its mother, it may have a different contribution to its phenotype that influence performance of the animals. So all of these answers are correct. So the number 17, the breed of the bull in the photo, it was a Charolais bull. It was a Charolais bull that Dr. Riley had showed y'all many times. And we know that Charolais bulls originated in Western Europe. They are indeed a terminal breed type. They are horned. And yes, many of them were imported to the United States from Mexico. They were not originated in Mexico. Number 18 is our linkage question. So in regards to extension in Tobiano locus, if a bay Tobiano stallion inherited a big E and a big T alleles from his sire, so he inherited this chromosome from his sire, and then little e, or little e, little t, from his dam, he has these chromosomes. And so 90% of the time, he will pass them on exactly how they are. So big E with a big T, or little e with a little t. So B is correct, A is incorrect. 10% of the time, however, crossing over happens. So 10% of the time, he will pass on a big E with a little t, and a little e with a big T, which is letter C. So the correct answer is E. So heterosis, and then moving on to number 19, heterosis, an important genetic tool in purebred systems of production. It is not for purebred systems, it is for crossbreeding systems. It is not the proportion of mitochondrial DNA. It is not mitochondrial DNA. It is not always favorable. You can see some detrimental stuff when you, with heterosis, such if you see lots of increased birth weights or mature cow weight, that's not always a good thing. And it is not always numerically positive. However, expression is proportional to breed heterozygosity. That is what we were talking about in labs most of the time. That's what I call direct and maternal hybrid vigor, is breed heterozygosity. This is what we are looking for. And then lastly, number 20, heterosis expectation. This is coming right out from y'all's notes. In fact, I have the slide right here. You see more heterosis in reproductive traits, growth traits, and than carcass traits. And you can see that right here. Heterosis is high in female fertility, moderate in growth, and low in production traits like loin-eye area, fat depth, that type of stuff. So that's coming straight from y'all's notes. So the correct answer is C.